Example 2, a smooth wall pipe line 3,500 long to connect the two reservoir and 77 meter difference. So this is the 7 meter difference between two reservoir A and B. Okay. And entrance is abrupt, so that is entrance we can find K for abrupt chain. The outlet is conical, so this is outlet. Okay. And there are two globe valve and 60-degree bend in the system. That is a globe valve, and this is a bend. Okay. If the cavity is caused to flow of water, what should be the diameter of the pipe line so that the discharge is 0.03 cubic meter per second, and assume water temperature is 20 degree. Okay, so the next step we have to identify what is the minor loss. You can look back to this. We can use okay. For the abrupt change, we can use this number for abrupt entrance, and for the conical we can use this number for K. For conical diffuser and globe valve, we can use K is equal to 1. And for bends we can use for 60 degree. This number we can use 0.45 for the bend. Okay, so that's when we use K is 0.5. This K is for globe valve. How much for a globe valve? 1. Okay, so that given the Q is 0.03 cubic meter per second, and head is 7 meter. In this case, we don't know we can analyze from this problem. We don't know the diameter. So in this case, if you don't know diameter, we don't know area and velocity. And if we don't know velocity, we don't know the unknown number, and finally we don't know the unknown friction factor. That's a problem. So we can start from the right energy equation from point A and point B. Okay, and this is energy equation. We have head loss on the right hand side. We will assume that the pressure is equal, PA, PB, and equal to P atmosphere, and velocity at point A in the big reservoir can be close to 0, and B will be as well. So this can be cancelled. This cancelled. The rest is ZB equal to Z A equal to ZB plus the head loss. Okay, so the difference of elevation is equal to the head loss from major plus head loss from minor. Okay, so for in this case we start from neglecting the our minor loss, assume that is turbulent flow. Okay, so we can assume that in the Moody diagram, if we assume, can assume any number for the number, but in this case I change this number to 10 power 4, so we get exactly the friction factor is 0.08. Okay, it's a smooth pipe. How to draw it to get this number? You can check from the Moody diagram, and we convert from the Darcy-Weisbach equation, substitute q in the velocity. Okay, and rearrange to get the d is a function of the other parameter. So we can solve that diameter is about 0.23 meter. And next we have to check velocity and check low number again, because the first is low number from assumption, from assuming, and from d. Okay, so we check the velocity, check velocity, check low number is about 1.65. And once we check again for the low number, try a new one, try a new little number. Actually we can use to 1.65. okay, we can try 1.3 and we get friction factor is 0.017. When we do again, we get the diameter is about the same, 0.229, and the velocity and little number. Okay, that is good enough to take the diameter is about 0.23. Okay, and this number is almost the same. So we can say that the diameter doesn't change so much from the difference of the little number. And next we think about including the minor loss in the equation. So this is minor loss that we read from the table, and this is for the equivalent pi. It's a beta time of diameter. So total minor loss, we can say that this from the axis, from entrance, entry, this from the axis, this from the globe valve, this from elbow. Okay, come up, we got like this point, just very small 0.13 meter. And again we put in the equation and solve again to find to plot the minor loss in the equation, and find the diameter is got the same 0.23. Okay. We can use the other method we call the equivalent pi method. We adding the pi length with the equivalent pi, and we only add 67 meter to the effective length and find the diameter. So almost the same from this number and this number. Okay, got the same diameter. We can come to conclusion that actually this one is this, and this one, the first is from the entrance again, and it's from axis, from globe valve, this from the elbow or the bend. Okay, and the loss through the fitting is in the long pi are little important in the determination of the pi diameter required. Okay,